Hello and welcome to our discussion on dual in a linear problem. Now, the problems that we have formulated up to this point have been the primals. That is, those are the primary objectives, those are the primary problems as we see them. There can be a different perspective of looking at the problem. So, that will be the dual of the linear problem, dual formulation of a linear problem. That there is the same problem, but we are looking from some different perspective. So, for understanding that concept, let us put up a question over here and then we'll form a primal of that and then we'll proceed to dual and see what is the dual perspective. So, the problem is over here. I do understand that you are well equipped with formulation of a linear problem, how the primal is formulated and how a primal is solved. The routine simplex problem is solved. So, if you are clear with that, then we can proceed with dual. So, assuming that you are clear with that, I will put up the problem over here, formulate the primal, and in lectures to come we'll solve also. But today's idea is only to concept what is the dual, how are primals and duals related. So, that will be the concept for today, that will be the idea for today. Now, here is the problem for you. The problem says an automobile manufacturer makes trucks and automobiles in a factory that is divided in two shops, shop 1 and shop 2. Shop 1, which performs basic assembly operations, must work 5 man days on each truck and 2 man days on each automobile. So, the business setup is organized in such a way that there are two shops, shop 1 and shop 2. On shop 1, 5 man days worth of tasks need to be performed for truck and 2 man days worth of task needs to be performed on an automobile. So, this is the idea at shop 1. Then the process moves to shop 2. These are not two separate plants, rather it is a continuation from shop 1 to shop 2. Shop 2, which performs the finishing operations. The first one was shop 1, which performs the basic assembly. Shop 1 was performing assembly operations, 5 man days for truck and 2 man days for automobiles. Then we come down to finishing job. In finishing, we are moving on to shop 2. There we have a requirement of must work 3 man days for each truck or automobile. So, it is 3 man days for either truck or automobile, whatever you are bringing at shop 2, it takes 3 man days for the finishing work. This is the idea. Then we have, if the manufacturer makes a profit of 3000 on each truck and 2000 on each automobile, find how many trucks and automobiles the manufacturer should make for a maximum profit. Also, we missed a line. Because of man-machine limitations, shop 1 has 180 man days and shop 2 has 135 man days per week. So, this is the idea. It is a very simple, straightforward problem, almost a problem that we took in first, second lecture for when we were learning formulation. So, again we will take a very simple problem for formulation to understand what is the connection between primal and dual. So, here is our problem and I will write down all the important information here for my reference. Also, our method suggests that we need to extract all the numbers from the given question. So, I will extract out all the given numbers from the question and put them over here in form of a table. Let us try to put them over here in form of a table. Is it possible to put them in form of a table? Yes, it looks like. What we can do is, we will leave this space for the question, we will start our formulation from here. We have trucks and automobiles. Then there is shop 1 and shop 2. Then on shop 1, the time required is 5 and 2 man days. 5 man days and 2 man days. And on shop 2, it is required as 3 for either truck or auto. Availability is, I believe, 180 and 135. Availability is 180 man days and 135 man days. Profits that we are getting from a truck and an automobile, 3,000 and 2,000. Each truck gets me a profit of 3,000. Each automobile gets me a profit of 2,000. Now this is the basic idea. All the numbers within the given problem are these. These can be formulated in this table. Now if you remember our basic formulation, the basic formulation suggests that on either of the axes we have our objective function, and we start coding or formulation of our problem from that objective function. Where is our objective function in this case? Either the objective function will be 3,000 and 2,000, these are profits. Either the objective function is 3,000, maximization of 3,000 and 2,000 profit, or it could be minimization of resources. When we talked about formulation, we talked that when both cost or consumption of resources and profit are given, our objective should be profit. Our objective is never minimization of cost, rather it is always maximization of profit. Yes, minimization of cost is a collateral. If you are getting it as a collateral, it is very good. But otherwise, my objective is maximization of my profit. There can be cases where you do not have profit, you only have costs. In that case, it could be a minimization of cost. In this case, we can clearly see that there is profit. So obviously, I will try to maximize my profit. I'll try to maximize the profit coming from trucks and auto. So what will be the formulation? If we go towards formulation of this, my formulation would have been, I wish to maximize my profit coming from 3,000. Now we need to give them some names. Now we could call this X1 and X2. If I am producing X1 number of trucks, then the profit would be 3,000 multiplied by X1 plus 2,000 multiplied by X2. This will be my total profit. 3,000 X1 plus 2,000 X2. This is my objective function. Then it is subject to certain constraints. What are the constraints? That if you are producing X1 number of trucks, you will be consuming 5 multiplied by X1 hours, 2 multiplied by X2 hours gone. Combinedly, these hours cannot exceed 180 in all, subject to certain constraints. What are the constraints? 5x1 plus 2x2 should be less than or equal to 180. This is the concept, this is the idea, that once we have the objective function, once we have the x1 and x2 plotted, it is straightforward. 5x1 plus 2x2 should be less than or equal to 180, because these are availability of hours. You can consume at most 180 hours, otherwise your consumption will be less. It cannot be more, so consumption is less. From shop 2, we are getting our second constraint, which is 3x1 plus 3x2. So it becomes 3x1 plus 3x2. 3x1 plus 3x2 should be less than or equal to 135. This is our third step, if you remember from our formulation. This is our fourth step. Fifth step would be physical constraints, non-negativity constraints. Those would be x1 and x2 should be greater than or equal to 0 at all times. Now, if we look at first step is declaration of profit. What is the objective function? Objective function is maximization of profit. Maximization of profit. This is my objective function. Then in second, we make all the declaration of decision variables. What is this? Z max. Then the variables that we are making use of are x1 and x2. x1 is number of trucks produced and number of automobiles. These are the 5 steps of our formulation of a primal. Now, why are we so keen in calling this primal? Up till this point, we have never called it primal of a problem. Today, we are calling it primal of a problem because we will be learning what is the dual of this problem. Now, let us create a partition so that we can have our dual in that partition. Here is a partition. Now, what is the concept of dual? Make use of this one. Now, what is happening in dual? Up till this point, we had a concept of 3000 x1 plus 2000 x2 should be maximized because these were the profits. Profit coming from one truck, profit coming from second truck. This was the idea up till this point. Now, what is happening is, suppose there is another investor. We as a business are working on this model, but there is some outside investor who is interested in investing into our resource. The resource that we are making use of, is Mendes. He is interested in investing into our resource. Now, if he is ready to invest, let us say he is ready to give me prices of Y1 and Y2. He is ready to give me Y1 rupees per Mende. He is ready to give me Y2 rupees per Mende at shop 2. Obviously, both labor will be different. Both Mendes would cost me differently. Because here they are involved into assembly, here they are involved into finishing task, finishing they are calling, I believe. So, they will be into assembly, they will be into finishing task, their costs can be different. Suppose the cost that the investor is ready to invest, the amount that the investor is ready to invest is Y1 per Mende at shop 1, Y2 per Mende at shop 2. So, if that investor is logical, if the calculations are logical, then the idea should be that whatever he is investing, what is he investing? 180 multiplied by Y1 plus 135 multiplied by Y2. 180 multiplied by Y1. Y1 is per Mende, Y2 is per Mende. So, total would be 180 into Y1. 180 multiplied by Y1 would be total that he would be investing in shop 1. The total payment that he needs to make for shop 1 is 180 multiplied by Y1. Total payment he needs to make at shop 2 would be 135 multiplied by Y2. His idea would be to minimize these investments. But obviously, this is my business. If I am allowing him to enter into my business, then my perspective cannot be denied. Okay, he will try to minimize this, but my idea would be that I am getting Y1 for this resource 180. So, whatever I am getting from this resource, that is 5Y1, this should be Zmin, because he will be trying to minimize the investment that he is making. But understanding that he will be minimizing this investment, my idea would be that whatever I am getting from here, I will be getting 5 multiplied by Y1, because he will give me Y1 for per Mende and I am using 5 Mendes in truck over here, then 3 Mendes in trucks over shop 2. So, my total collection would be 5Y1 and 3Y2. This is my total collection from shop 1 and shop 2. He is as an investor is giving me this price Y1 and Y2, and as a manufacturer I will be getting 5Y1 and 3Y2 from trucks division. So, I will be getting 5Y1 plus 3Y2. Now, this collection should be more than or equal to 3000, because in absence of that investor also I am making a profit of 3000 rupees. As it is, I am making a profit of 3000 rupees. Now, when that investor steps in, he starts charging me for the supply of raw material, in this case Mendes. When he starts charging me something, whatever collection I am making, whatever rate I am quoting to him, that okay, we are ready to quote you Y1 and Y2, that should give me either 3000, at least 3000, or definitely preferably it should be more than 3000. So investor is coming to invest in my business and I'll accept the proposal of that investor only if what I'm getting from him, 5y1 plus 3y2, is at least 3000 or more than 3000. This is the idea. The investor is having a rational perspective of minimizing these two, 180y1 plus 135y2. But as a manufacturer, because I am allowing him to invest in my business, that proposal should be lucrative. That proposal will be lucrative if I am getting 5y1 plus 3y2 more than 3000. Same is with second case from auto department, subject to this was our third step, third step, this is our fourth step. I should be getting 2y1 plus 3y2 should be more than 2000. Now as a logical investor, he will be looking for a deal which minimizes his investment. But as a manufacturer, I would only accept that investment if my profits are maximized. If I am getting 3000 or more, I'll accept this opportunity if I am getting 3000 and 2000, but preferably it should be more. But at a minimum level, it should be 3000. Whatever I am getting from truck division should be 3000 or more. Under 3000 I am not accepting, because as it is I am making a profit of 3000 from truck department. So this is one truck from shop 1, one truck from shop 2. Completely one truck has been produced at this cost, 5y1 plus 3y2. And whatever I am getting as this investment opportunity, the other one is investing and I am getting a revenue. Whatever I am getting should be more than 3000. If that is the case, I am accepting this opportunity, otherwise I am not accepting this opportunity. If we try to formulate first step, we have objective function which is saying Zmin total investment by prospective investor. And in this case, second, what is y1 and y2? These are the decision variables this time. What is y1? Per Monday, that prospective investor is ready to pay. At shop 1. Y2 becomes at shop 2, what he is ready to pay. And obviously, we would want these y1 and y2 be greater than or equal to 0. Whatever he is paying me, at most he can pay me 0. At least he can pay me 0. It cannot go into negative zone. So, I have y1 and y2 greater than or equal to 0. So, we see that that very same problem can have two different perspectives of looking at it. In absence of any investor interest, this was my problem formulation. But as soon as I change the perspective, as soon as I see that there is an investor who is ready to invest in my mandates, in my raw material, in my labor, then the perspective shifts. Now, he'll be having in his mind, the investor will be having in his mind that 185 y1 plus 135 y2 should be minimized. But during this deal, my perspective would be that whatever I am getting from here, it should at least be 3000 or more than 3000. This should be more than 2000. So this is dual of this primal. Now if we see over here, what has happened from 3000 x1, 2000 x2, 5x1 to x2, we have shifted to 183 y1 plus 135 y2, 5y1 plus 3y2. The axis has completely changed. This is the concept of dual. This is the concept of looking at the problem from a different perspective. This is the relationship between primal and dual. And we can see the axis that was giving me objective function has become the constraint in dual, and the axis which was giving me constraints in primal has given me objective function in dual. This is how it gets flipped in dual. So in lectures to come, what we'll do is, we'll look at more formulations of these and we'll see why we go into dual formulation. The concept is this, the reality is this. From here on, we'll be talking only about formulation of dual and how to solve a dual. What is the relationship between primal and dual? I believe we have seen over here. So next time when we meet, we'll try out some more formulations of dual. And why at all should we go for dual? Why is it? So that we need a different perspective to look at the problem. This is what we'll see in lectures to come. This was it for our today's discussion. Until we meet next time, do take care. Thanks for watching. Bye-bye.